All right, so we're going to start part 4 of this section of notes, and that is solving quadratic equations by finding square roots in the form of ax squared plus c equals 0 or a number. We've just been doing a lot of quadratic equations in this form. So in this case, that b is 0, so there's no middle term. So we take that trinomial where b is 0, and we're just going to have something x squared or something squared plus a whole number equals 0, and we're going to solve for that. All right, so your steps are to isolate the x squared on one side of the equation, and then step 2 is find the square roots of each side, because the square root of an x squared equals that root number. All right, and we're going to talk about this being a positive or a negative a little bit here in the notes. So just if you were going to do a problem, let's say 2x squared, or no, let's just do 2x because you guys know how to do these. So 2x plus 4 equals 10. All right, and if you are going to undo this with inverse operations, you subtract 4 from both sides, because whatever you do on one side, you have to do on the other, right? 2x equals 10 minus 4 would be 6. Then we have to undo this, so we divide by 2. So that would be x equals 3. All right, so that is a two-step equation to solve for a variable. Now, when we're dealing with squares, we can take it one step further. So if I take this same problem and I say 2x squared plus 4 equals 10, then I subtract 4 from both sides, so I get 2x squared equals 6 again. Divide by 2, x squared equals 3. Now I'm at that step 1. You isolated x squared by itself. All right. Now to undo an x squared, you could take the square root. So you could take the square root of x squared, then that's going to give you x. So I can take the square root of 3, because whatever I do on one side, I have to do on the other. That's going to equal the square root of 3. All right. And then I'm going to put a plus minus here, and we're going to talk about that in a second. But the whole thing is that you can get that x squared portion by itself, and your last step is going to take the square root of both numbers. All right, so moving down in the notes, if I get to a point, in this second to last step right here, where I had, I'm just going to undo this, where I got to this point, you see anything disappear from my screen, where you have the x squared isolated by itself and it equals a number. All right. So in this case, relate this to x squared equals d. In this case, d equals 3, right? So if d, in this case 3, or if the number is greater than 0, there's going to be two solutions. So when you do take the square root of both sides, you will get x equals plus or minus 3, or the square root of 3 for your answer. All right? If d happens to come out to equal 0, there's only going to be one solution, and that solution is going to be 0. And if d, if this happened to be a negative number, you're going to say there's no real solution, because there's no two negative numbers that are going to multiply out together to equal a negative number. They're always going to be positive. All right, so here's a couple examples to apply this. You can see that these already have the x squared already isolated by themselves. We didn't have to do any of the work like before. So if I just say, hey, if x squared equals 4, what could x equal? Well, to undo that, you can take the square root of both sides, because whatever you do on one side, you have to do on the other. So the square root of x squared is going to be x, and the square root of 4 is going to be 2. Now, because that d is greater than 0, we're going to make sure that we have a plus or minus here. So in a sense, this is saying that x can equal negative 2 or positive 2. All right? Because if I put negative 2 in, back for x, negative 2 squared, negative 2 times negative 2 does equal 4. So that checks out. That works. And 2 times 2, 2 squared, also equals 4. So for most of these, there's going to be two answers, the positive and the negative answer for these cases. All right? So over here, you have an x squared, so you have to take the square root of both sides, which is what we did here. The square root of x squared is just x without the square root. And the square root of 5 is, going to be a crazy decimal, so we can just leave that as the positive and negative version of root 5. If you want to do that, if you want to put in your calculator the square root of 5, you want to round maybe to the nearest hundredth and call it plus or minus 2.23. you can also do that. So this could also be plus x equals plus or minus square root of 2, oops, not the square root, sorry, plus or minus 2.23. And we're just going to round. So go ahead and try these. These are pretty straightforward. So I have x squared equals 81. So x squared equals 81. Take the square root of both sides. Square root of anything squared is just that root. So the square root of 81, you can go to your calculator if you want. So I'm going to clear this. The square root of 81 gives us, oh look, 9. This is a nice calculator. It's the Desmos.com scientific. So if you don't have a calculator at home, this is one to use. I found it pretty helpful. So we know that x would equal 9, but remember, because we have the x squared in a positive number by itself, we're going to put that plus or minus there, because negative 9 squared equals 81 and positive 9 squared equals 81. For this one, again, take the square root of both sides. So y, square root of y squared equals y, equals plus or minus the square root of 11, or you can say y equals plus or minus the whatever the square root of 11 is. So you can say square root of 11, 3.3, and that 6 would round that to a 2, so we can call it 3.32 if we round to the nearest hundredth. So 3.32. All right, so these are the same idea here. So you take the square of both sides, you'd have n equals, the square root here, square root of 25, type that in. That would be plus or minus 5. And then square root here, x equals, and you can leave this as plus or minus the square root of 10. Now going back to our previous ones, if we want to simplify it and leave it in radical form, we could do the breakdown, but these don't reduce to anything other than just that square root. But if you want to round to a decimal, you can do that. Okay, so now here's another example. Now we have what looks more like the problem that I did to start off this lesson. So we need to now isolate x squared by itself. Well, what's our first step? We have to undo this. So we're going to add 48 to both sides. So this gives us 3x squared equals 48. All right, then we have to keep undoing it. So we're going to divide by 3. Use a different color here. So we're dividing by 3. So hey, what's 48 divided by 3? So 48 divided by 3, that gives us 16. So we're going to go ahead and write that in. So x squared equals 16. Now we're at basically what we did in the previous two problems. We're going to take the square root of both sides, because the square root of x squared is just x. And then we have to figure out what the square root of 16 is. If you don't know that already, go back to your trusty calculator. Square root of 16 equals, gives us 4. So we are going to go back and say x equals, and then remember that plus or minus right there, right? Because a negative 4 times a negative 4, if I plug this back into the calculator, will make it true. If I type in a negative 4, 3 times negative 4 squared minus 48, that will come out to equal 0. All right, so those are the steps on how you do those problems. Go ahead and pause it here and try these two problems. I'm going to go ahead and go through them. So for here, I need to get the x squared by itself. So to do that, I have to add 1 to both sides. Then I rewrite it as x squared equals 1. And now to get the x squared by itself, we have to do the inverse operation of something that's squared, and we take the square root of it. That gives us x. But I also have to take the square root of this side, because whatever we do on one side of the equation, we have to do exactly that operation on the other side. The square root of 1 is just 1. So that would be our answer. But make sure you put that plus minus there. All right, because a negative 1 would make this true. If you just put 1, you're basically only half right. So make sure we get in the habit of doing that. All right, if I come over here, 2x squared minus 72 equals 0. So we add 72 to both sides. I get 2x squared equals 72. So your next step is dividing by 2. That gets our x squared isolated. So you go back to your calculator. What is 72 divided by 2? That gives us 36. Alright, so we have x squared equals 36. Then we have to solve for x, so now we are going to get rid of that squared by taking the square root. So going up here now, we have x equals, and then what's the square root of 36? We go back through and we can go ahead and type it in if you don't know it. Square root of 36, that gives us 6. So, plus or minus 6. All right, just another sample problem. If you see something like this, and this is kind of where the negative part comes in. Let's say I have 2x squared plus 16 equals 0. All right, the first step on this problem would be to subtract 16 from both sides. So that would be 2x squared equals negative 16. Next step would be to divide by 2. So then I have x squared equals negative 8. So now going back in the notes, this is what I mean by if you have an x squared that comes out equal to a negative number, you will just say no solution. So if you get to that point in the problem and you recognize that, make sure you are marking that, and you don't just go ahead and blindly put the square root of both sides, because if you put the square root of a negative number, and if you're doing it correctly, you'll see here. So if I do the square root of negative 8, it says, oh, undefined. It gives you kind of an error message, maybe on your calculator at home. So that's how you know to put no solution in there.